Hello guys, my name is Prince and this is Math Center. Subscribe to my YouTube channel for more videos. Post your comments and questions on my social media handles and I'll respond to it. We are on the topic number basis. This is the last video on number basis. In the previous video, we learned how to draw tables for a given operation in a given number base. In this video, we are going to tackle number basis that involves equations or equations in number basis. So let's pick some examples. Equations involving number basis. So the question says that we should solve for x in the following. So we pick them one after the other and we solve it. Let's pick the first one. We are supposed to solve for x in 3 2x base 4 is equal to 56. So we are supposed to solve for x here. Now how do we go about this? You see that we have 56 here. There is no base attached to it, which means that it's in base 10. We have 3 2x base 4 here. So to solve them, they all must be in the same base. Now we have 56 in base 10. So we can easily convert 3 2x base 4 also to base 10. So we have 3 2x in base 4. We can convert that to base 10. Then we equate it to 56, which is already in base 10. And we start solving from there. We know how to convert numbers from a given base to base 10. The x here doesn't change anything. It follows the same principle. We know that to convert a number to base 10, you have to multiply every digit in the number with the base. So you begin by, you multiply x 3 with 4, you multiply 2 with 4, you multiply x with 4. Then you order the bases. So 0, 1, 2. So you see nothing changes. It's the same principles as we have been doing all along. We have 3 times 4 squared is 16 plus 2 times 4 exponent 1 is 4 plus x times 4 exponent 0 is 1. So we are going to have 3 times 16 will give us 48. 2 times 4 will give us 8. X times 1 will give us x. From algebra, we know that 48 plus 8 plus x will give us 56 plus x. Since 48 plus 8 will give us 56, then plus x. These are not like terms, so we have to leave them like this. If you watch the video on algebra, you know why this must be left like this. So we are going to have 56 plus x. So we now have 3 2x base 4 also in base 10. In base 10, we are going to have 56 plus x. This side is already in base 10, so we can equate this to that. So we say that we now know that 3 2x base 4 is the same as 56 in base 10. Now 3 2x base 4, if you convert that to base 10, we are going to have 56 plus 4. So this is 3 2x base 4 is 56. 3 2x base 4 is also 56 plus x. So we can equate this and that. So we can say that x plus 56 is equal to 56. Since it's the same 3 2x base 4, 3 2x base 4, so you can equate this and that. Now we solve this. This is a linear equation, so we solve it. We know that we have 56 here, we have 56 here, numbers, so we can group like terms. We group the x at one side, we group the numbers at one side. There is only one x here, so we are going to keep it here. 56 is here, we take it to the other side, it's positive. When you take it to this side, it's going to be negative. So we are going to have x is equal to 56 is positive here, so when it comes here, it becomes minus 56. So we say that x is equal to 0. So the x in this equation here is 0. So it means that 3 2x base 4 is actually 3 20 base 4, since we have found x to be 0. It's pretty simple, right? Let's pick the next example. 4 4 1 base x is equal to 121. Now remember, 121 is already in base 10. So what you have to do is now convert 441 base x to base 10. Once again, nothing changes. It's the same principles that we use. You know that to convert a number to base 10, what you have to do is that you first multiply the number with the base. So you first multiply 4 by x, and 1 by x. Then you order the bases. This time x is the base, so you order the x's. So you have 0, 1, and 2, just as we have been doing as usual. So this is going to give us 4 times s squared to give us, so it's going to be the same 4 times s squared plus 4 times x, s exponent 1 is the same as x, plus 1 times, now s exponent 0 is 1. Remember I said any number or variable exponent 0 is 1, so x exponent 0 is also 1. 4 times x will give us 4 times s squared will give us 4s squared, plus 4 times x will give us 4x, then plus 1 times 1 will give us 1. If you watch the video on indices, you will understand that 4s squared and 4x are not like terms, so we can't add them. So you leave this one like that. 4s squared plus 4x plus 1. So we have now converted this whole thing here to base 10, and we are having 4s squared plus 4x plus 1. This is already in base 10, so it means that we can equate this here and 121. So you say that 441 base x is equal to 121. 441 base x is also equal to 4s squared plus 4x plus 1. So you can equate these two. So you equate 4s squared plus 4s plus 1 to 121. So we group like terms. These are the x's, so we send the x's to one side, then we send the numbers also to the other side, or we group them at the same position. So we want to bring this one here. It looks like we are having a quadratic equation, so you write it in such a way that the quadratic equation will be clear for us to solve. So we bring 121 from this side, we bring it to this side here. It's positive, so when it comes here it becomes negative. So we are going to have 4s squared plus 4x plus 1 minus 121 is equal to 0. And this is going to give us 4s squared plus 4x minus 120 to give us 0. Now this is an example of a quadratic trinomial. In the videos on algebra, we dedicated a whole video into treating quadratic trinomials. If you watch that video, you will see how to solve this quadratic trinomial. Once again, I'm going to explain that in this video on the calculator for you to see. So I said that to find this, whenever you have a quadratic trinomial like this, you first have to identify your a, b, and c. So in this video, our a will be 4. Our a is 4. Then b is also 4. B is equal to 4. Okay, so b is also 4. Then c is equal to negative 120. So a is 4, b is 4, then c is also equal to negative 120. So I said that to find the two numbers that you use in expanding this trinomial, the first thing you need to do is after you've identified all this, you multiply your 4 by, you multiply your a by the c. So in this case, a is 4, c is negative 120. So if you multiply a by c, you are going to have, sorry for this, so 4 times 120, that will give us 480. Now since it's negative here, it means you are going to have negative 480. So if you multiply a by c, you are getting negative 4, then 80. So a by c is given as negative 480. Now you go ahead to use your calculator to find it. So you press on, then you go to mode, you pick equation 5, you pick the third one, then a is 4, b is 4, C is negative 120. Then you press enter. Now the first answer is 5. We said that whenever you get your first answer, here is positive, so you pick it as negative. So you are going to pick it as negative 5. You multiply that with a. So if you multiply negative 5 with a, which is 4, you are going to get negative 20. It means that one of the numbers is negative 20. If you want the other number, divide the first number, which is negative 20, by your a times c. Our a times c is negative 480. So if you divide negative 480, so it means that you have to clear your calculator now. So you are clearing the calculator. If you divide negative 480 by negative 20, you are going to have 24, which means that the two numbers we are looking for are negative 20 and 24. Those are the two numbers that you replace 4x with. If this what we are doing here looks clumsy, watch the video on algebraic expression, on factorizing quadratic trinomials in algebraic expression, and you will understand what we are doing in this video. We dedicated a whole video on how to use our calculator to find those two numbers when we are factorizing quadratic trinomials. So the two numbers we are looking for are 24 and negative 20. So we replace 4x with 24x and negative 20x. So we are going to have 4x squared plus 24x minus 20x minus 120 is equal to 0. So we are factorizing. We can factorize 4x out. We are going to have x plus 6. Once again, if you watch the video on algebraic expressions, factorizing algebraic expressions, you understand how this factorization is done. Here, we can factorize 20 out. So you factorize 20 out, you are going to get x plus. Now, as I said in algebraic expressions, if you are factorizing and we have a negative sign outside the bracket, the sign inside the bracket must change. So the sign here was negative, it will change to positive. So plus 6 will give us x plus 6 will be equal to 0. So we now have x plus 6 in this bracket, x plus 6 in that bracket. So we pick one of them, then you pick the ones outside the bracket. So we have 4x minus 20 in one bracket, then x plus 6, you pick one of them, is equal to 0. Now we can see from here that we have 4x minus 20 in one bracket, then x plus 6 in another bracket, and they are all equal to 0. Remember that if you have two things being equal to 0, it's either the first one is 0 and the second one is not 0, or the first one is not 0 and the second one is 0, or both of them are 0. So here, in order to find x, we equate each one of them to 0. So we equate the first bracket to 0, we equate the second bracket to 0. So we pick the first bracket, you equate it to 0, such that we can find x. Now we have 4x minus 20 will be equal to 0. We take the brackets off since there is no number outside here to multiply. So we have 4x minus 20 to be equal to 0. Solving linear equations, we know that we have to bring the 20 to this side. 20 is negative. When it comes here, it becomes positive. Watch the video on solving linear equations and you see how this is done. So we divide both sides by 4. We divide here by 4. We divide here by 4. 4 will cancel itself. 4, so here we'll be left with x. 20 divided by 4 will give us 5. So we have our first x to be 5. Now you go to the second bracket. In the second bracket, we know that we have x plus 6 is equal to 0. If you take the brackets out, we have x plus 6 will be equal to 0. Then x to be equal to negative 6. So you see from here that we have two values for x. We have x will be equal to 5 and x to be equal to negative 6. Now, both of them can't be true. Only one of them will be true. Now, let's look at our question. In the question, x is a number base. Remember that it is 4, 4, 1 base x. So, x is a number base. Now, a number base must be a positive whole number. Since x is a number base, it must be a positive whole number. Number bases are not negative. We have not seen any negative number base here. So the number base must be a positive whole number. So we look here, we have 5, we look at this side, we have 5 and negative 6. So among 5 and negative 6, which one is a positive whole number? That is 5. So it means that x is 5. See, after solving, we got x to be 5 or negative 6. Both of them can't be true. It means that one is true. So we pick the one that satisfies the condition that we are working with. In the condition that we are working with, we are saying that x, the value we are looking for, must be a positive whole number since it is a number base. So in this case, x will be 5. Let's look at the next example. We have 211 base x is equal to 320 base 4. So once again, we have this one here in base x, we have this one here in base 4. They must all be in the same base. So we convert this to base 10, we convert this one also to base 10. So in converting 211 base x to base 10, we use the same principles as we have been doing. So we have 2 times x plus 1 times x plus 1 times x, then you order them, so 0, 1, 2. Remember, this time x is the base, so the powers will be given to the x's. So this is going to give us 2 times x squared plus 1 times x plus 1 times 1, since x exponent 0 is 1. So this will give us 2x plus x plus 1. So it means that we have converted this to base 10. If you watch the video on algebraic expressions, you will see that x squared, 2x squared and x are not like terms, so you can't add them. So we leave our answer like this, 2x squared plus x plus 1. Now we have to convert this one also to base 10. So in converting 320 base 4 to base 10, we have 3 times 4 squared plus 2 times 4 exponent 1 plus 0 times 4 exponent 0. That will give us 3 times 16 plus 2 times 4 plus 0 times 1. 3 times 16 will give us 48. 2 times 4 will give us 8. 0 times 1 will give us 0. 48 plus 8 will give us 56. 56 plus 0 is still 56. So now we have converted 211x to base 10. We had 2x squared plus x plus 1. We have converted 320 base 4 to base 10. We had 56. So we can equate what we converted here and what we converted here. So if you equate them, you are going to have 2x squared plus x plus 1 is equal to 56. Now this is a quadratic equation, so you bring this here so that you can have equal to 0 here. So you are going to have 2x squared plus x plus 1 minus 56 is equal to 0. And this is going to give us 2x squared plus x minus 55 is equal to 0. Once again, if you watch the video on solving quadratic trinomials in the videos on algebraic expressions, you understand how to break this down. So in breaking this down, we are going to have 2x squared minus 10x plus 11x minus 55 is equal to 0. Watch the video on solving quadratic trinomials and you see how we got negative 10x and positive 11x here. If you are factorizing this out, if you watch the video on factorizing algebraic expressions, you see that this will give us 2x into bracket x minus 5 plus, so here we can factorize 11 out, we factorize 11, get x minus 5 is equal to 0 here. So we have x minus 5 here, x minus 5 here, so you pick one of them, then you pick what you have outside the bracket, so 2x plus 11 is equal to 0. So we solve them by equating each one of them is equal to 0. So you equate x minus 5 is equal to 0. You're going to have x minus 5 is equal to 0. Then x is equal to 5. Then we solve for the second bracket too. So we have 2x plus 11 is equal to 0. So in solving for linear equations, this is going to give us 11 is positive here. When it comes here, it becomes negative. So you're going to have negative 11 divided by 2 to give us x. If you watch the video on solving linear equations, you understand how x is negative 11 divided by 2. Because you bring 11 here, it becomes negative 11. You divide both sides by 2, so you're going to have x to be equal to negative 11 divided by 2. Now, once again, what is x? X is the base of a number, or a number base. S is a number base. Number bases are positive whole numbers. In this case, S is giving us 5 or negative 11 over 2. So to find x is a positive whole number since it's a number base. So you can see that x is equal to 5 since it is a positive whole number. Thank you for watching this video and all the videos on number bases. Pick more examples on solving equations involving number bases. One thing about these equations is that they usually lead to quadratic trinomials. So watch the video on algebraic expressions, the one that teaches how to solve quadratic trinomials. Then use the same principles in solving the quadratic equations that we have here. Try your hands on this example so that you become conversant with it. If you have any problem, don't hesitate to interact with me on my social media handles and I'll help you to solve them. Bye bye.